RBM, that is restrictive Boltzmann machine. Basically, it is a type of artificial neural network. Here we are talking about RBM. RBM is a type of artificial neural network for machine learning of probability distribution. Basically, it is a generative stochastic artificial neural network which can learn a probability distribution over its set of inputs. We are using here RBM. So, RBM is a neural network which helps us generate the new data sets. So, it is a kind of generative artificial neural network. It is basically useful for regression, for classification, for dimensionality reduction, feature learning, maybe for topic modeling and collaborative filtering. So, this RBM, it was invented by Geoffrey Hinton in the year 1985. Restricted Boltzmann machine, RBM, it falls under the category of unsupervised learning algorithm. It is a network of symmetrically connected neuron-like units that make the stochastic decisions. We have talked earlier about the supervised learning and the unsupervised learning. So, this category of RBM, it belongs to the unsupervised learning algorithm. So, this deep learning algorithm, they became very popular after Netflix competition. In the Netflix, here RBM was used. It was used as a collaborative filtering technique to predict the user rating for a movies. And so, because Netflix nowadays it has become very common, it is almost being used in every house, every place. So, there RBM has played a major role. How? It distinguishes or it predicts the user rating for the movies. Whatever you're watching on the Netflix, rating has to be given to that for the user, and depending on that only the next movies will be recommended to you. So there what we are applying? We are applying the restrictive Boltzmann machine, RBM. So basically RBM is a type of artificial neural network which is used for machine learning of probability distribution. Basically, our RBM, it is a category of unsupervised learning algorithm. Here, we are not using supervised learning algorithm, we are using unsupervised learning algorithm. And our RBM, it was invented by Geoffrey Hinton in the year 1985. Let us talk about the features of our restricted Boltzmann machine. So, restrictive Boltzmann machine, it is basically an artificial neural network. So, the basic features of this RBM, restrictive Boltzmann machine, is like, first, they use the recurrent and symmetric structure. Recurrent structure means we do have certain feedback paths, the recurrent paths. So that is why here RBM, restrictive Boltzmann machine, they use a recurrent structure. Then symmetric structure it provides. RBM, in the learning process, they try to associate high probability with the low energy states and vice versa. So RBM, the next feature of RBM, that is restrictive Boltzmann machine, is that in the learning process, they try to associate the high probability with the low energy states and vice versa. Third, very important thing here in RBM, that is restrictive Boltzmann machine, is there are no intra-layer connections. We are having independent layers, we do not have the intra-layer connections. It is an unsupervised learning algorithm, that is, it makes the inferences from the input data without the labeled responses. So RBM, it is a special case of Boltzmann machine with a restriction that the neurons within the layer, they are not connected. That means there are no intra-layer communication, which makes them independent and easier to implement, as conditional independence is there. Means that we need to calculate only the marginal probability, which is easier to compute. So that is why RBM are now being used in various entertainment industry, in various shopping apps that we have nowadays, because RBM, they are having no intra-layer connection, no intra-layer communication, so which makes them independent and easier to implement. As the conditional independence, so we need to calculate only the marginal property. So it is much easier to compute. So that is why we use RBM, restrictive Boltzmann machine, more often nowadays. So RBM, the main features of RBM, it is they use the recurrent and symmetric structure. Next, the RBM in their learning process, they try to associate the high probability with the low energy states and vice versa. Third very important thing is there are no intra-layer connections. That is why it makes it easier to compute the probabilities of the data. Fourthly, it is an unsupervised learning algorithm. That means it makes inferences from the input data without the labeled responses. Talking about the working of a restrictive Boltzmann machine, or RBM, it is an unsupervised learning algorithm that we've just discussed. We have a visible layer of neurons which receives the data. Like we normally have in a neural network, a layer of neurons which receive the input, and after that some weights are multiplied by the inputs and they are added to the bias value at the hidden layer neuron to generate the new output. The output value which is generated at the hidden layer neuron, it will become a new input which is then multiplied with the same weights, and then bias of the visible layer, they will be added to regenerate the input. So this basic process, this is called reconstruction or backward pass. The output value which is generated by our hidden layer neurons, they will become now the input, which will again be multiplied with some weights and then bias of the visible layer, and they will be added to generate the input. So this process, it is called reconstruction or even the backward pass. Then the regenerated input, it will be compared with the original input if it matches or not. The process, it will keep on happening until the regenerated input, it is aligned with the original input. Because our RBM, restrictive Boltzmann machine, it is a form of generative model. Here we are trying to generate the models, the data which is similar. So that is why the process, this process, it will keep on happening until the regenerated input, it is aligned with the original input. RBM, how does it work? Here we have a visible layer of neurons which receives the input data, and this input data, it will be multiplied by the weights and some bias values are added to it at the hidden layer to generate the output for the next layer. Then the output value generated at the hidden layer, they will become the new input, which is again multiplied with some weights and then bias of the visible layer, they will be added to generate the input. This basic process, this is called reconstruction, or we can say backward pass. Then the regenerated input, it will be compared with the original data, original input that we have, if it matches or not. So this process will continue till our data will match with the input data, because we are trying to generate the similar data values here. So this process, it will keep on happening until the regenerated input, it is aligned with the original input. So that is the basic function, the basic working of our restrictive Boltzmann machine. Let us understand it. The working, the main purpose of this RBM. Let us understand it with example. Suppose we have a 6 set of movies. You must have heard about them like Avatar, Billion, Avengers, Gravity, Wonder Woman and Fast and Furious. So, these movies will become the visible neurons, and the latent features which we are trying to learn, they will become the hidden neurons. Like all these kind of movies, they belong to different categories. So, here these movies, they will function as the visible neurons, while the latent features of them which we are trying to learn, they will become the hidden neurons. Here like Avatar, Billion, Gravity, they will fall under the category of sci-fi movie genre, and the remaining, here 3 of them, they will fall under the thriller category. So we have a thriller category there, movies which are thriller, movies which belong to sci-fi. So thriller and sci-fi, they become the hidden neurons of the hidden layer, which are the features which are extracted from the input. Our input here is what? Our input is these set of movies that we are generating. Now we categorize them into different categories. So if a user like thriller movies, then our RBM, restrictive Boltzmann machine, it can find movies which are turned on by the hidden neuron thriller. And the hidden neuron, they will send the messages to the visible neurons to update their states. And this will work as a movie recommendation engine. Like what taste movie a person prefers. So only that taste of movies will be recommended to him. Similar to that. So that is how our RBM, restrictive Boltzmann machine, plays a role there. So in our entertainment industry today, we have been using this RBM very frequently. So here we use a set of movies. If we have a set of movies, we can categorize them into different categories. And depending on that, if a person like a thriller movie, if a person likes sci-fi, if a person like horror movies, so similar to that, only the movies will be recommended to them. So that is how this RBM, these neural networks, they are making so much of usage in our industries nowadays. Talking about the advantages and the disadvantages of RBM machines. First of all, talking about the advantages, first, it is expressive enough to encode any distribution and computationally efficient. Our RBM machines, they are computationally efficient. They are ready, they are enough to encode any distributions of the probabilities. Now, these restrictive Boltzmann machines, they are faster than our traditional Boltzmann machines due to the restriction in terms of connection between the nodes. Here we have understood that our RBM, there are no intralayer communication between them. So, in terms of that, these RBM machines, they are faster because we have the restriction in terms of the connection between the nodes. The activation of the hidden layer, they can be used as input to other models as a useful features to improve the performance. Even the activations of the hidden layer, whatever activation our hidden layers are performing, they even can be used as input to other models to improve the performance of our models. So these are the basic advantages of a restrictive Boltzmann machine. Talking about the disadvantages, first one, training is more difficult as we are trying to calculate the energy gradient functions. In this, we are trying to calculate the energy gradient functions. So training the RBM machines becomes difficult. Now, in every neural network, we are at the backend using various algorithms. So CDK algorithm, which is used in RBM, it is not as familiar as the earlier backpropagation algorithm that we understood. We have many familiar algorithms like the backpropagation algorithm and many more. So the CDK algorithm that is being used in our restrictive Boltzmann machine. So it is more difficult because people are not very much familiar with this. When we are taking the data as input, we are multiplying it with some form of weights. So the weight adjustment part, it is more difficult in case of restrictive Boltzmann machine. So talking about this restrictive Boltzmann machine, here the adjustment part of weight, the weight which we are multiplying with the inputs, so that becomes more difficult. So these are few advantages and disadvantages of our restrictive Boltzmann machine. Use cases of RBM, or we can say application. Where all do we apply our restrictive Boltzmann machine? The very first application is pattern recognition. RBM, restrictive Boltzmann machine. It is used for feature extraction in the pattern recognition problems, where the challenge is to understand the handwritten text or a random pattern. So there we can apply our RBM machine, where we are trying to understand the pattern of somebody's writing. So RBM, they are highly capable for extracting the features from the input data. So that is why we can definitely use them for the purpose of pattern recognition. So RBM, it is used for feature extraction in pattern recognition problem. Here in pattern recognition problem, the main challenge is to understand if there is handwritten text. So every person has a different style of writing. So in that case, or maybe for a random pattern we are talking, so there, in that case we can apply our restrictive Boltzmann machine. Second, the recommendation engine, RBM. It is widely used for collaborating the filtering techniques, where it is used to predict that what should be recommended to the end user, so that the user enjoys using a particular application or a particular platform. Like if we are talking about the particular website which recommends us certain books, we have so many websites now which deliver, if we are reading some of the book in our tabs, in our laptops, so some new books might be recommended to us. If you're watching movies, so new movies will be recommended to us. So there all we can apply our restrictive Boltzmann machine. So it can be definitely used in our recommendation engines. Third, the radar target recognition. Our intra-pulse feature extraction of the radar. It is of high significance as it suffers from the challenge like the data representation capability and the robustness to cope up with the noise. So RBM there, it is used to detect the intra-pulse in the radar system, which have a very slow SNR and the high noise. So in that case, for the radar target recognition, we definitely can use our restrictive Boltzmann machine. So there are many more use cases, many more applications of our RBM. For now, we have discussed it can be used in the pattern recognition. It can be definitely used for in the recommendation engine. It can also be used in the radar target recognition. Stacking RBM. Stacking means putting on into a stack, putting the RBM machine in a stack. So there, a deep belief network. It can be visualized as a stack of restrictive Boltzmann machine, where the hidden layer of one RBM, it is a visible layer of the RBM above it. Hidden layer of one RBM, it might be the visible layer of the RBM which is above it. So we can stack different RBMs together. So the output from the previous RBM, it becomes the input for the following RBM. So that is called stacking RBM. So our deep belief network, it learns a hierarchical representation of the inputs and it aims to reconstruct the data. Therefore, it is very useful, especially in the unsupervised setting. For continuous input, one can refer to another model like continuous restrictive Boltzmann machine, which utilize a different type of contrastive divergence sampling. Such models, they can deal with image pixels or maybe word vectors that are normalized for the results. So basically, stacking RBM, what does it mean? Our deep belief network, we can visualize is at the stack of restrictive Boltzmann machine. Our restrictive Boltzmann machine, how does it work? The output of one will work as the input for another. Stack is what? When we have, like you can consider a stack of books. When you have placed one book on top of another book on top of another, output of one will become input for another. Similarly, the output of this will become input for the above one. So basically, stacking RBMs are a deep belief network. We can visualize it as a stack of restrictive Boltzmann machine where the hidden layer of one RBM, it will be the visible layer of the RBM which is above it on the stack. The output from the previous restrictive Boltzmann machine, it will become the input of the following restrictive Boltzmann machine. So DBM, it learns a hierarchical representation of the input and it aims to reconstruct the data. Therefore, it is very useful especially in the unsupervised settings.